Hello everyone, I'm Chen Jing, come from Nanjing University, China. I'm very pleased to be here to join this conference. The topic of my presentation is Measuring Radical and Incremental Innovation of Digital Product by Text Analysis of Mobile Apps Updates. As is shown in the picture, my presentation will include these four parts. First, some background information about this research. Second, the theory of mobile apps innovation and the metrics for innovation. Third, the data we got and the method we use. And last, some findings we have got. In recent years, digital products have played a dominant role in economic development. Millions of entrepreneurs have been engaged in developing mobile apps and providing digital services via their products. The rapid development of mobile commercial has brought the mobile apps market into a prosperous era. According to statistic reports, Google Play has 2.87 million apps and the Apple App Store released 1.96 million apps in the third quarter of 2020. Although mobile apps have broad prospects, the market is no longer a blue ocean. The massive effect can be observed in the fierce competitive of mobile apps. In other words, those apps which have first mover advantage accumulate more advantage over time, while those which began with a disadvantage have a lower and lower probability of succeeding. At present, mobile apps with a high degree of interest are most divided among Internet giants, especially Facebook, Google, and Apple. Thus, the essential question for developers is how to gain a competitive advantage in the fierce competitive market. One critical solution is innovation, which enables mobile apps to acquire new users or maintain survival. On the one hand, innovation can open new markets for apps and gives apps irreplaceable competitiveness. On the other hand, innovation makes apps quickly respond to the refinement and changes in users' needs. However, there is a huge difference between digital products like mobile apps and physical products. Apps continuously evolve through updates during the life cycle. Most apps gradually gain users' recognition and competitive advantages through continuously innovation iterations. Some popular apps see updates as frequently as weekly. Others release once or twice per month. Thus, the innovation of an app is not only a process from 0 to 1, but more importantly, a process from 1 to infinity. Knowing how innovative the app is critical in achieving a competitive advantage in the market. This study aims to propose a method to measure the innovation output of mobile apps in the third-party mobile app stores. Specifically, update documents of mobile apps serves as a unique data source to measure the innovation. The update document is a demonstration that depicts the reverse activities that developers have created in the new version of the apps. An update is a behavior whereby software replaces an installed version of a product with a newer version of the same product. A newly updated version may include many new features or revised appearance. For instance, 10.1.88 version of Alipay includes two update points, namely color upgrade and performance optimization for a smoother experience. In this study, every update point is regarded as one output of innovation of the app. Previous explorations into update of the apps have been mainly based on three dimensions: degree of updates, update frequency, and update type. Considering the degree of innovation, Christensen took the lead in defining disruption technological innovation and incremental technological innovation. Incremental innovation, also named continuous innovation, means that this type of technology enables products or services to improve existing performance in accordance with those aspects that most users in major markets have always valued. Correspondingly, disruptive innovation or radical innovation refers to radically new products that involve dramatic leaps in terms of customer familiarity and use. Many previous studies have been proven that frequent updates make for better market applicability. Marvin conducted a study on the update frequency and unveiled that the identified positive effect on frequent updates can be elicited only with functional feature updates and not with technical no-feature updates. In other words, the type of updates has a moderating effect on the positive impact of update frequency. The classification of apps update types is quite diversified, and there is no unified classification system yet. Combined with the previous literature and the analysis of update text, we divided the update types of apps into 9 categories: functional updates, business updates, version improvements, existing function improvements, systematic improvements, bug fix, adaptability adjustment for iOS system, new content, and activities. Metrics for innovation have become a hotspot in the field of innovation research. Edison, Ali, and Torka summarized existing measurement systems into the following modes: R&D-based measures, revenue-based measures, IPR-based measures, count-based measures, as well as process, investment-based, and survey measures. R&D-based measures are used for innovation inputs, while revenue-based measures are used for innovation performance. And it is not hard to understand the process, investment-based, and survey measures work for estimating organizations' innovative capabilities. IPR-based measures are the major way to measure innovation output. Patent counts, citation-based volume, and patent density are the most widely used metrics. Nonetheless, patent only covers a certain type of innovation. Considering the high frequency and multiple types of apps innovation, IPR-based measures tend to ignore a great deal of non-patented innovations and inventions. Therefore, IPR-based measures are obviously not the best choices for innovation of apps. In summary, update count seems to be the most effective metric in measuring app innovation. However, count-based measures also have significant flaws in that they treat the quality and degree of all innovation outputs the same. In order to overcome this defect, this study applied the theory of radical innovation and incremental innovation to the measurement system, as the following picture suggests. The first 3 kinds of updates are always accompanied by guidance steps within the app for making users adapt. From the perspective of users' familiarity, they have made major changes. Therefore, we classify them as radical innovation, while the other types are considered as incremental innovation. As for the data, information about 4,516 apps from Apple iOS China was gathered and organized. Some apps were dropped from the analysis as they received very few reviews and gained limited attention from the users. Finally, we screened 39,153 pieces of update documents from 2,645 apps from Apple iOS China. Each has effective update documents and at least 10 reviews posted by users from January 1st, 2019 to December 31st, 2019. As previously mentioned, before formal analysis, update documents should be divided into update points. For the sake of readability, developers usually describe an update point in one line in the update document. Consequently, we separated the update text by line breaks and treat each line of text as a potential update point. Furthermore, some apps repeated previous updates in the latest version of update documents. We removed all of the duplicate content by identifying the keywords recent updates. Finally, a total of 144,783 pieces of text were obtained. The analysis includes 3 steps: content analysis and coding, text mining and automatic classification, and update-based measuring. Content analysis is a semi-quantitative research method, which is widely applied to the study of update documents of apps. However, since its work is mainly done manually, this method is only suitable for a small number of samples. Considering there are over 100,000 pieces of text to be dealt with, utilizing machine learning methods for text mining has become an inevitable option. Therefore, we first built a training dataset with content analysis and utilize it as input data to discipline the classifier. After that, we counted the number of updates of each category of each app and scored them in the dimension of incremental innovation and radical innovation. The coding scheme in step 1 was established according to the table below. And it is worth noting that some invalid texts are inevitably recognized as update points during the data pre-processing, such as welcome messages, thank yous, event previews, update previews, activity descriptions, function descriptions, developers' content information, and information for which it is impossible to automatically determine whether it is an update point. Those have been placed into another category, an A, which means not an update point in this procedure. To summarize, the complete coding scheme includes 3 primary calls: radical innovation, incremental innovation, and not an update, as well as 10 secondary calls. Approximately 10% of the samples, namely 14,415 pieces of text, were randomly extracted for manual coding. One team member created the coding scheme, and the other 2 were assigned to code the text separately. After 3 rounds of coding, the Scott-Street index of the 2 coder reaches 0.764. Finally, the remaining borderline and difficult cases were resolved by the first author. In step 2, a variety of machine learning models were applied to classify the sample set, including fast text, text CNN, text RNN, text RNN attention, text RCNN, TP-CNN, transformer, and BERT. In the training process, we adopted a 5-4 cross-validation method, taking 20% of the data as test set and 80% of the data as training set, repeated 5 times. Ultimately, the BERT model performs best, with an accuracy rate of 81.71%, while the accuracy rates of other models were all lower than 76%. As a result, the BERT model was selected as the final classifier. After completing the classification, we extracted 100 results from each category of the final results to test the usability of the constructed classifier. The recall rate and the precision rate of each classification exceeded 18%, which meets the accuracy requirements and proves the reliability of the classification results. In step 3, every update point is measured on the 9 categories with the classification algorithm. For example, if a specific update point represents the content of functional updates, the functional update dimension is measured as 1. Next, the value considers the radical innovation dimension. Each update is measured in the 2 dimensions of incremental innovation and radical innovation by aggregating their values on the 9 categories. In this section, we combine the app types, innovation types, and degree of innovation with spirals visualization methods to demonstrate and explore the app's lack of innovation in depth. As previously indicated, app innovation output has obviously polarization. Nearly 10% of apps scored 0 in radical innovation in 2019. On the contrary, 35 apps performed very well in this aspect, with a score of over 100. To present this phenomenon more intuitively, we cluster the evaluation results of innovation through the K-means algorithm. After 13 iterations, the final clustering result is shown in this picture. The innovation performance of apps show a gradient distribution. The number 1 cluster accounts for 30 of the whole. Over 90 of apps in this cluster have excellent performance in both incremental and radical innovation. They are most likely to be the exploratory or growth period in the life cycle of software. For apps in the growth stage, speedy acquisition of new users through radical updates is top priority. Meanwhile, it is necessary to quickly release incrementally updated versions based on user feedback to increase users' retention. The number 2 cluster is the gathering place for killer apps such as Alipay and Taobao. Those apps already have a stable stock of users, and there is room for growth in the number of users. The number 3 cluster only consists of 19% apps. However, the characteristics are clear at a glance. They concentrate on developing incremental innovation in most cases, because the user groups are basically fixed, or they have technological innovations that are difficult for competitors to imitate. Apps in the number 4 cluster are more cautious about innovation. Relatively speaking, these apps were rarely updated in 2019 and most never ranked high in the iOS hot list. Nevertheless, WeChat, which is the most well-received instant messaging app in China, surprisingly belonged to the number 4 cluster. There is no doubt that WeChat has become an essential app for almost everyone in China. For such a unique app, the risk of innovation, such as increase of input costs, users' dissatisfaction with updates, probably far outweighs benefits. Apps in the same field tend to imitate the successful ones to maintain functional equivalence, and the updates most usually maintain a certain degree of consistency in the sample of this study. Therefore, we calculated the average value of innovation performance for each type of app to observe the update patterns. According to this figure, the radical innovation scores of 3 types of apps, shopping, travel, and finance, are among the top 3. As for the radical innovation dimension, game apps outshine others. The game industry has always been an important branch of the mobile application industry. The most obvious features of game apps compared to others is that the new versions contain a lot of update points. Amongst updates, it is not difficult to see that the incremental innovation in contact and activity is most essential, accounting for over 14% of daily updates. Holding periodical seasonal events and adding new characters, costumes, and props are the main ways for mobile games to keep users enthusiastic and make profits, rather than business updates. In addition, the properties of new characters and props are often modified based on users' feedback, which is primary content of existing function improvement. Another interesting finding is that the updated patterns of shopping, travel, and finance apps are extremely similar, as shown in this figure. All of them did well in the dimension of radical innovation. Improvements to existing figures are the dominating weight involved incrementally, which accounts for approximately 20%. In addition, they also take notice of visual innovation and improvements. Compared with mobile games, users' familiarity with interface operation is not necessarily required. That's all for my presentation. If you have any questions, please feel free to contact me. And here is my email address. Thanks for your attention.